Hello guys, welcome to my walkthrough of the AQA June 2017 Higher GCSE Maths Paper 3. So I'm doing these again so that I can do them better and also put them all in one place, which is a playlist with every past AQA Higher 9 to 1 paper in the same place, which you can find linked down below in the description. Also down there are useful bits and bobs to help with your revision and topics from this paper. Let's do this. Okay, question 1, we have column vectors. So A is -4 -1 and B is 3 -1. We want to find the value of 2A add B. So 2A is just 2 times the two numbers, so -8 -2. So 2A add B is -8 -2 add 3 and then add -1. So that's going to give us -5 and -3. So there he is. Good times. Okay, question 2. Which of these values of n make 2.7 times 10 to the n a cube number? Okay, so we got 2.7. 27 is a cube, which is 2.7 times 10 to the power 1. So n is 1. Is our guy. Okay, question 3. Rearrange 2x equals y over w to make w the subject. In other words, get w all on its own. So, if we multiply through by w, we get 2wx is equal to y. We could rewrite that as 2x w is equal to y. Now we need to get rid of the 2x, which is multiplying the w, so we divide by 2x, we get w is y over 2x. There it is. Ideal. Okay, question 4, we have bearings. So we want to work out the bearing of C from A. So that means if we're at point A, what bearing do we have to walk on to get to C? So, north is always 0 degrees, and you always measure bearings clockwise. So we want these two angles added together. So 130 and 80 is 210. Which is that? Cool. Okay, question 5. A coin lands on tails 200 times. The relative frequency of tails is 0.4. Work out the total number of times the coin was thrown. Okay, so 0.4 is 40%. So 40% of total throws is the number of times it landed on tails, 200. So from that, we could work out what 10% was by dividing both numbers by 4. So 10% would have been 50 times by 10 to get 100% is 500. Cool. Question 6. How are the whole number solutions to A and B different? 2 marks. So, okay, so we got inequalities. So, let's have a look. For A, we have 3 less than or equal to 3x less than 18. So if we divide 3 by 3, we get 1 less than or equal to x, which is less than 6. So here, x is equal to 1, 2, 3, 4, and 5. And then for B, very similar. So this time we got 3 is less than 3x less than or equal to 18. Divide by 3 again, we get 1 is less than x is less than or equal to 6. So here, x is not allowed to equal 1. It can be 2, 3, 4, 5, and 6. So, that would do it. Good times. Okay, question 7. So this is the first thing that you'll find linked down below in the description. Topic-wise, we have error intervals. So the length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of the pipe. So, whenever you do any type of rounding, you make an error. The error interval is the range of values that the actual length of the pipe could be before we do the rounding. So for the lower interval, the lower bound, we think what is the smallest number that would round up to 6 to the nearest whole meter. Now that would be 5.5. And then for the upper bound, notice that you have a strict inequality. So we use the first number, the smallest number, that wouldn't round down to 6. So that would be 6.5. That would round up to 7. So the reason that we use a strict one is if we used an or equal to one, we could say 6.4, 6.49, 6.499, 6.4999999 forever. So it gets a bit silly. So instead of doing that, we use a strict one with the upper bound as the first number that wouldn't round down. Okay, then part B. We're told the length of a different pipe is 4 meters to the nearest meter. Ollie says the total length of the 2 pipes is 11 meters to the nearest meter. We want to give an example to show that he could be correct. Okay, so let's do the error interval for this second pipe, so let's call it L2. Now the lower bound would be 3.5 and the upper bound would be 4.5. So let's think of 2 lengths of these pipes that would add together and round to 11. So we could go 6.4, and then we could add 4.4, which would give us 10.8, which is 11 meters to the nearest meter. Cool. Okay, question 8. This shape is made from 2 triangles and 4 congruent parallelograms. Congruent means exactly the same. So for each statement, we want to tick the correct box. So the triangles are equilateral. Okay, well, we know because these parallelograms are congruent, we know that these 2 sides of the triangles are definitely the same. We don't know anything about the third length though. It could be the same, it could not be the same. So for that one, we can only say could be true. Okay, and then for the second one, the triangles are congruent. Well, the triangles are formed from exactly the same parallelograms, so the triangles are definitely the same. So that must be true. Okay, question 9. There are 720 boys and 700 girls in a school. The probability that a boy chosen at random studies French is 2/3. So that means 2/3 of the boys study French. The probability that a girl chosen at random studies French is 3/5. We want to work out the number of students in the school who study French. Okay, so we need to find 2/3 of 720 and 3/5 of 700. So your calculator can do this. Do 2/3 times 720. As 2/3 of 720, well, 1/3 is 240, so that's 2 times that is 480. And then for the girls, 3/5 of 700, well, 1/5 is 140, 3 times that is 420. So altogether, 480 and 420 is going to give us 900. Cool. Okay, then for part B, we want to work out the probability that a student chosen at random from the whole school does not study French. Okay, so we know that 900 of them do study French. Well, we need to know how many students there are in total. So 720 add 700 is 1420. Now we need to find the number that do not study French. So 1420 minus 900 is 520. So the probability they don't study French is 520 out of 1420. Cool. Okay, question 10. We have a nice angle problem. So A, B, C, D, and E, F are all straight lines. Ava assumes that A, B, and C, D are parallel. What answer should she get for the value of angle Y? So angle Y is this guy. Okay, now we got 2 angles involving X and another angle involving W. Now, if AB and CD are parallel, then 2x add 10 and 3x minus 20 are corresponding angles. Corresponding angles are equal. So we can set them equal to each other. So 2x add 10 is equal to 3x minus 20. Now we want to solve that for x. So if we minus 2x from both sides, we get 10 is x minus 20, and 20, then we get x is equal to 30. So now that we know that, we can work out the size of this angle. So 3 times 30 minus 20 is 70. So this angle is 70 degrees. So y and that angle lie on a straight line. Angles on a straight line add up to 180. Take away the 70, y is 110 degrees. Cool. Okay, then for part B, we are told, in fact, AB and CD are not parallel. Angle W is 60 degrees. What effect does this have on the size of angle Y? Okay, so if W is 60 degrees, then we also know that 2x add 10 is equal to 60 because these angles are vertically opposite. So now let's find the value of x in this case. So 2x add 10 is equal to 60. 2x is equal to 50. Divided by 2, x is 25. So if x is 25, 3 times 25 minus 20 is 75 minus 20, which is 55. So this angle would now be 55. So now we know y add 55 is 180. So y would be, take away the 55, 125. So we just got that y was 110. So the size of angle y is bigger. So it says show working, just pull your answer, we've just done that on the diagram. Okay, question 11. Purple paint is made by mixing red paint and blue paint in the ratio 5 to 2. Jan has 30 litres of red paint and 9 litres of blue paint. We want to know what is the maximum amount of purple paint he can make. So what's going to happen here, we're going to run out of either red or blue paint first. So what this ratio is saying, red to blue, if it's 5 to 2, it means we mix 5 litres to 2 litres. So let's try using all of the red paint. So we got 30 litres of red, so we've multiplied 5 litres by 6, so we would need to do the same to 2 litres, but that's going to give us a problem because we would need 12 litres of blue, so that isn't right. So let's try red to blue, 5 litres to 2 litres. Okay, so let's try using all of the blue paint. So we got 9 litres of it. Now what we need to know is how have we gone from 2 litres to 9 litres. So 9 divided by 2 is 4.5. So we've multiplied by 4.5. So we need to do that to 5 times 4.5 is 22.5. So altogether, the purple bit is going to be 22.5 add 9, which is 31.5 litres. Cool. Okay, question 12. See what we got here. A r to the b all to the power of 4 is equal to 16r to the power of 20, where a and b are positive integers. We want to work out a and b. Okay, so let's just look at the left hand side. So a r to the power of b to the power of 4. Okay, so when you have multiple letters or different types of term inside of a bracket, the power affects each term. So we're going to get a to the power of 4, and then we're going to get r to the power of b to the power of 4. When powers are separated by a bracket, they multiply together. So we're going to get r to the 4b. Now let's compare that to the right hand side. So we got 16r to the 20. So that means that a to the power of 4 has to equal 16. So a is 2. 2 times 2 times 2 times 2 is 16. And the powers of r have to be the same. So 4b has to equal 20, which means b is equal to 5. Cool. Okay, question 13. So this is the next thing that you'll find down below in the description. Reverse mean. So, in a class of 28 students, the mean height of the 12 boys is 1.58 meters. The mean height of all 28 students is 1.52 meters. We want to work out the mean height of the girls. Okay, so remember, to work out mean, you do the total divided by the frequency. So we got two statements here, two sentences, telling us about a mean and a frequency. So we got the mean height of the boys and the mean height of the class. So we can rearrange the formula to get the total is frequency times the mean. So what we can do, first of all, let's work out the total height of the class. So we know there are 28 students in the class, and the mean is 1.52. So we do 28 times 1.52, and that gives us 42.56. Now if we do the same for the boys, so we find the total height of the boys, we can then find the total height of the girls by taking the boys away from the whole class. So the total height of the boys well, that's going to be 12 times their mean height, which was 1.58. Now that gives us, where's it gone? That's going to give us 18.96. Now we can work out the total height for the girls. By doing the total height of the class, so 42.56 minus the total height of the boys. Now that's going to give us 23.6. Now that's the total height of the girls. We need to know how many girls there are. So there are 28 students, 12 are boys, there are 16 girls. So the mean of the girls is 23.6 divided by 16, and that gives us 1.475. Cool. Okay then, 14. X, Y is equal to C, where C is a constant. We want to circle the correct statement. So, we got Y is directly proportional to X. Y is inversely proportional to 1 over X. Y is directly proportional to 1 over X. X is directly proportional to Y. So, what we're going to do, if X, Y is equal to C, most of those statements are about Y, something to do with X. So let's divide by X. So we get Y is C over X. Now, what we can see is Y is inversely proportional to X. But that isn't one of our options. But we can now rule out Y being directly proportional. And we can rule out X is directly proportional to Y. So, it's one of these two. So, they're trying to trick us here because this is inverse proportion. So Y is inversely proportional to X. But, as we've said, that's not one of our options. So, what happens is as C over X gets bigger, Y gets bigger. So the correct one is that Y is directly proportional to 1 over X. Okay, number 15. The graph shows the depth of water in a harbour for 12 hours. D is the depth of water in a harbour in meters, and T is the number of hours after 9 AM. So there's the graph. So we got depth going up the side, time going along the bottom. Part A asks for how many hours of the 12 hours is the depth more than 5 meters. So let's find 5 meters. So it's here. So it's more than 5 meters all the way to over there, and then don't forget we have to check this bit over here. So it's more than 5 meters over here as well. So we got that bit and this bit. So the first bit is 7 hours, and then we got this bit at the end which is another 1 hour. Altogether, that's 8 hours. Part B says, by how much does the depth change between 12 noon and 4 p.m? So remember, we start at 9 a.m. So 12 noon is 3 hours after that. So we're going to go up from there, and then 4 p.m. it's going to be 4 hours after that, so 7 hours. So we need to find the depths at these times. So going up from 3, we get a depth of 8. And then we're going to cross by 4 hours. So that is going to be that point there again. This guy here. So that was a depth of 5. So we've gone from 8 to 5. The depth has changed by 3 meters. Okay, question 16. The value of a new car is £18,000. The value of the car decreases by 25% in the first year, 12% in each of the next 4 years. We want to work out the value of the car after 5 years. So there's quite a few ways that we can do this. I'm going to use decimal multipliers. So 25% is 0.25. Now when the car decreases by 25%, we are essentially taking 25% off the price or the value. So 1 minus 0.25 is 0.75. So if we multiply 18,000 by 0.75, we are finding 75% of 18,000. So up to here, we could work out 18,000 times 0.75. That would find us the value of the car after the first year. I'm not going to know, because we can do this all in one go. Now 12% is 0.12. So when the car decreases by 12%, it goes down to 88% of its value. So 1 minus 0.12 is 0.88. So, if we multiply the value after the first year by 0.88, that's then going to give us the value after the second year. Now, we know now that it decreases by 12% for the next 4 years. So what we're going to do is stick the power of 4 on the 0.88, and that is going to give us 8,095 pounds 89p. Cool. Number 17, probably one of the trickiest questions on the paper. So Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles per hour for 1 hour 36 minutes. He finds this information about his car. So if the average speed is 65 miles per hour or less, it uses 50, or it can get 50 miles per gallon of petrol. if he's going at more than 65 miles per hour, he can go 40 miles per gallon. We want to use the information to show that he uses less than 3 gallons of petrol. Okay, so first up, let's deal with the 9 miles in 9 minutes. So, 9 miles in 9 minutes means 1 mile in 1 minute, which means 60 miles per hour. Okay, so for the first bit, he's going at 60 miles per hour. So he can get 50 miles per gallon of petrol. Now, he has gone 9 miles. So he has gone 9 out of the 50 he could go with 1 gallon. So if he's gone 9/50ths of the distance that 1 gallon could take him, he's used 9/50ths of a gallon. So 9/50ths is 0.18. So up to there he's used 0.18 of a gallon. Now for the second part, let's see, he had an average speed of 70 miles per hour for 1 hour 36 minutes. So we need to work out the distance that he's gone there. So speed is distance over time. So distance is speed times time. Now what we need to do is work out 1 hour 36 minutes as a decimal of an hour. So 36 minutes is 36/60ths of an hour, which is 6/10 or 0.6. So 1 hour 36 minutes is 1.6 hours. So his distance is 1.6 times 70, which is 112 miles. So here he has travelled 112 miles. Now we know at this speed he can get 40 miles per gallon. So to work out how many gallons he's used, we do 112 divided by 40 and we get 2.8 gallons. So altogether he's used 2.8 gallons and 0.18 gallons, which is 2.98 gallons, which is less than 3. Good times. Okay, question 18. Nick sketches the graph of y equals 0.5 to the power of x, 4x greater than or equal to 0. we want to make one criticism of his graph. So there's only really one thing that we can look at. We've only got one value. It's this here. On the y-axis, x is equal to 0. So on the y-axis, y is equal to 0.5 to the power of 0, which any number to the power of 0 is 1. So our criticism is that his y-intercept is wrong. So it should be 1, not 0.5. In question 19, circle theorems. So I've got plenty of stuff on this. Check out my playlist down below. So A, B, C, and D and E are points on a circle. We're told BFD and AFC are straight lines. DC is equal to DF. Now our mission, as always, is to work out the size of angle X. We must show our working, which may be on the diagram, and it's 4 marks. Okay, so first off, because these two lines are the same length, FCD is an isosceles triangle. So this angle is the same as this angle. Right, next up, we need one of our circle theorems. So when you have a circle and you have a message and also this sort of situation, this angle is equal to this angle and that angle is equal to that angle. So do we have that sort of situation? Yes, we do. So we got that going on. So thanks to that theorem, we know because this angle up here is 24, this angle here is also 24. Now we know angles in a triangle add up to 180. These two angles down here are equal. So if we do 180 minus 24, we get 156. If we do that divided by 2, we get 78 degrees. So now we know this chap is 78. Much more importantly though, this guy is 78. Now we got these three angles that lie on a straight line, x, 2x and 78. So angles on a straight line add up to 180. So x add 2x add 78 is 180. 3x add 78 is 180. Take 78. 3x is 102. Divide by 3, x is 34 degrees. Cool. Question 20, we have bounds. So the sign shows when the lift is safe to use. So the total mass of people must be 450 kilograms or less. Ben and some other people are in the lift. Their total mass is 525 kilograms to the nearest 5 kilograms. Ben gets out. He has a mass of 78 kilograms to the nearest kilogram. Is the lift safe to use? You must show your working. Okay, so we need to think of worst case scenario. So the heaviest possible mass of all the people in the lift, and the least possible weight of Ben. So for that, we're going to do the error intervals for both parts. So the error interval for the mass in the lift, call it L, well, it's 525 kilograms to the nearest 5 kilograms. So the lower bound is the smallest number that would round up to 525 to the nearest 5 kilograms. So that's going to be 525.5. And then the upper bound is the smallest number that wouldn't round down to 525. So that's 527.5 kilograms. So the worst case scenario for mass in the lift is 527.5 kilograms. Okay, now let's do the same for Ben. So Ben is 78 kilograms to the nearest kilogram. So the lower bound of Ben is 77.5 and the upper bound of Ben is 78.5. So when we're talking worst case scenario, we want to have the biggest possible mass in the lift to begin with, and then we're going to subtract the smallest possible mass of Ben. So we're going to do 527.5 minus 77.5, and that gives us 450 kilograms. So that is the greatest possible mass left in the lift. So the greatest possible mass still in the lift is 450 kilograms. So yes, it is definitely safe to use. Cool. Okay, question 21. So we got a sketch of the graph of y equals f of x, where f of x is a quadratic function. We're told the graph intersects the x-axis, where x is minus 2.5 and x is equal to 1. What we want to do is circle the solution of f of x is greater than 0. So what that means is, what values of x produce the part of the graph that is positive, so above the x-axis. So it's going to be x has to be greater than minus 2.5, but less than 1. So let's try and find that. So start that first one. It is this one. Good times. Now we have a quadratic sequence, so I'll put my sequences playlist down below. So we want to work out the nth term of the quadratic sequence to 17, 40, 71, giving our answer in the form an squared add bn add c, where a, b and c are integers. So the first step is to find the differences. So 2 to 17 is 15, 17 to 40, 23, 40 to 71 is 31. Second step is to find the second differences. 15 to 23 is 8. 23 to 31 is also 8. Now, half of the second difference tells us how many n squareds there are in the sequence. So half of 8 is 4. So the quadratic part is 4n squared. Now quadratic sequences on the whole are made up of a quadratic part, which we've just found here, and a linear part. So we now need to find the linear part, which we do by taking the quadratic part away from the original sequence. So 4n squared means 4 times the square numbers. So the first square number is 1, 4 times 1 is 4. Second square number is 2 squared, which is 4. 4 times that is 16. Third square number is 9. 4 times 9 is 36. Fourth is 16. 4 times that is 64. So what we now do is subtract these terms from the corresponding terms in the original sequence. So for example, we're doing 2 minus 4, which gives us minus 2. 17 minus 16, which gives us 1. 40 minus 36, which gives us 4. 71 minus 64, which gives us 7. So that is the linear part of our sequence. Now to find the nth term of these, find the differences, which is 3. So it's something to do with 3n. If you set n equal to 1, you then compare it to the first term, which is minus 2. 3 times 1 is 3, so how do we get from 3 to minus 2? We minus 5. So the whole nth term is 4n squared, add 3n minus 5. Cool. Okay, 23. Here is a sketch of y equals x squared, add bx, add c. So it's quadratic. The curve intersects the x-axis at 5, 0 and point P, and the y-axis at 0, minus 10. We want to work out the x-coordinate of the turning point of the curve. Okay, so with a quadratic, the number at the end is the y-intercept. So from that, we know that c is equal to minus 10. So up to here we can say y is x squared add bx minus 10. Now we know that we hit the x-axis at 2 points, P and where x is equal to 5. Now remember, when you factorize and solve quadratics, when you've got it in factorized form, the signs of the solutions are the opposite of the numbers in the brackets. So given here that we got x equals 5, that tells us when we factorize this, we're going to get x minus 5 times x plus or minus a number. But what we know is that these two numbers need to multiply together to give us minus 10. So the other number that goes in here is going to be plus 2. Now this would give us, if this was equal to 0, this would give us x is equal to 5, which we already knew, and x is equal to minus 2. So we know the coordinates over here at P are minus 2, 0. Now the x value of the turning point is the midpoint of the two x-intercepts. So the midpoint of minus 2 and 5 let's say minus 2, 0 and 5, 0 is minus 2 and 5 over 2, 0. And now minus 2 and 5 over 2 is 3 over 2, which is 3 halves, 0. So the x-coordinate of the turning point down here is 3 over 2, or 1.5. Now we're not asked to find the y-coordinate, so we're done. If we wanted the y-coordinate, we would expand these brackets to get the quadratic. In fact, let's just do it. So if we expand those brackets, we get x squared minus 3x minus 10. So to get the y-coordinate of the turning point, we would substitute x equals 1.5 or 3 halves into that. But the answer that we care about is just 3 halves. Cool. 24. A ball is thrown from a point 6 meters above the ground. The graph shows the height of the ball above the ground in meters. So we got meters going up the side, time going along the bottom in seconds. We want to estimate the speed of the ball in meters per second after 1 second. We must show our working. Okay, so speed is distance over time. Now, at 1 second, what we need to do, when you got a graph like this, the gradient of the curve gives us the speed, because speed is the rate of change of distance over rate of change of time, or changing time. So when you find the gradient of a line, it is finding you the rate of change. So what we need to do is draw a tangent to the curve at 1 second. So at this point here. So let's see how well this is going to go. Okay, so that just about works. So what we want to do now is work out the gradient of this line. So gradient, remember, is difference in y over difference in x. So we need 2 nice coordinate points. So we got this first one, which is at 1, 8. Now we need to try and find another nice one. which doesn't look like we have, so that's annoying. Okay, let's use the y-intercept. So here we know t is 0. The x-coordinate is 0. And then we got 6.6 for the y-coordinate. So the gradient is 8 minus 6.6 over 1 minus 0. So that's going to give us 1.4. Now up on top, remember we have meters, on bottom we have seconds. So this is 1.4 meters per second. Cool. Okay, 25. So rectangle ABCD is the horizontal base of a triangular prism ABCDEF. We are told that AE is equal to BE. So that means this length is equal to that length. So it's an isosceles triangle. And we're also told E is vertically above M, the midpoint of AB. We're given those other lengths as well. So E is vertically above M, and M is the midpoint of AB. We want to show that EM is 15 centimeters. Sure. We know that AB is 16. So this whole thing is 16. We also know AE is 17. So that also means this length is 17. And we also know that BC is 30. So that's the length of the prism. Okay. So we want to work out the length EM. So we can turn this into a right angle triangle problem. We can say that AM is 8. Because it's half of AB. So now we can use Pythagoras. So by Pythagoras, 17 squared minus 8 squared will equal EM squared. Now 17 squared is 289. So we get 289 minus 64 is EM squared. That's going to give us 225 is equal to EM squared. Therefore, EM does indeed equal 15. Cool. Okay, so part B then wants us to work out the size of angle ECM. So this is trigonometry in a 3D shape. So EC is this line here. So what I like to do with these is pull out a 2D drawing of what we're doing. So we've just worked out that this is 15 centimeters. This is E, this is M. Now, EC is going to be that line there. So that is going to be the hypotenuse of a right angle triangle. And then C to M runs along the diagonal of the base. So, what we're trying to find is this angle here. Let's call it theta. So, we know one length of this triangle. If we can work out the other, then it's SOHCAHTOA. So, luckily, we can work out the other. The green line, MC, is a right angle triangle. So, let's pull out a little sketch of that as well. So imagine that we are looking down from above. There's the base of our prism. So we know that M is the midpoint here. Now we know that this is 8 centimeters. Now we also know the whole length of this rectangle is 30. So what we can do is use Pythagoras to work out that length there. So let's just call it x. So we know then that by Pythagoras, 8 squared and 30 squared is equal to x squared. 8 squared is 64, 30 squared is a number 900. So we get 964 is equal to x squared. So if we square root that, we get x is the square root of 964. So I'm just going to leave that like that. So all that's now done for us, it's given us this base length here. So now we can work out the angle. So 15 is the opposite, root 964 is the adjacent. Go to SOHCAHTOA, it's TOA, T-O-A. So tan of theta is equal to 15 over root 964. So theta is the inverse tan of 15 over root 964. See what that is. So that's going to give us 25.79 degrees. I would always go to 2 decimal places if they haven't specified, just to be safe. Cool. Okay, question 26. A nice 6 marker, so the biggest question on the paper. So we got an L shape. All lengths are in centimeters. Now we're told the area of the L shape is 65 centimeters squared. Work out the value of x. Okay, so we know the area numerically. Now we have algebra kicking around in the lengths. So what we need to do is work out the area algebraically as well, and then we can set the algebra equal to 65, solve, and it's going to be a great time. So what we're going to do is, as with any compound shape, split the bugger up into 2 rectangles. Now the area of this guy over here then is going to be x times 9. So 9x. Now we know the height of the other rectangle is 3x add 1. What we need to work out is the length of it. So the whole thing has a length of 10. We know up here we got x of that. So this bit is 10 minus x. So the area of this part in here is 10 minus x times 3x add 1. So we need to expand that. So we're going to get minus 3x squared. We're going to get minus 1x. We're going to get add 30x. And we're going to get add 10. So that is minus 3x squared. Add 29x minus, add 10. So the total area algebraically is, the total area is the 9x minus the 3x squared, add the 29x, add 10, now if we sharpen that up, we've got minus 3x squared, add 38 x, add 10. Now we know that that is equal to 65 because they are both the area of the same thing. Cool. So what we now need to do is solve this. So it's quadratic. Now what we don't want is a negative x squared term. So I'm going to write it the other way around first of all. So 65 is minus 3x squared. Add 38x. Add 10. So we're going to move everything on the right over to the left. Whenever you are solving quadratics, you always want everything on the same side and a 0 on the other. So we're going to add 3x squared. We're going to subtract 38x. And we're going to subtract 10. So we now got 3x squared minus 38x and 55 is equal to 0. So now we need to try and factorise this. So we're going to need a 3x and an x. Now not many things multiply together to give us 55. In fact, it's only going to be 5 and 11. Now, given that we have a negative number in the middle, but a positive number at the end, both numbers are going to be negative. Now, if we put an 11 there, then we get minus 33x from the expansion, and then a minus 5 there gives us the minus 5x we need to get down to minus 38x. So, this now gives us two possible solutions for x. Remember, what we do is set whatever is inside the bracket equal to 0 and solve for x. Now, if x minus 11 is equal to 0, x is 11. Or, if 3x minus 5 is equal to 0, 3x is equal to 5 and x is equal to 5/3. So, as it stands, we have two possible values for x, but one of them probably won't work. So remember, the whole base length of the whole shape is 10. If x was 11, then this part up here is longer than the whole shape, which is ridiculous. So x can only be 5/3. Cool. And the final question wants us to prove that x squared and x and 1 is always positive. So this guy is a quadratic. Quadratics, like this. If it's always positive, that means the turning point or the minimum of the curve will be above the x-axis. So how do we find the coordinates of that point? We complete the square. So x squared add x add 1. So I've got a whole playlist on completing the square, and I think algebraic proof is rattling around somewhere. They will be down below in the description. So to complete the square, we need a single set of brackets with a square and an x inside. You half the number on the x term, so half of 1 is a half. Then we got the plus 1 on the outside. Now we square the number inside the bracket and take it away on the outside. So a half squared is a quarter. So we're taking a quarter away on the outside. So we end up with x add a half squared add 3/4. So what we found is the coordinates of this point are minus a half, positive 3/4. So the important part from that is that the minimum value is 3/4, so x squared add x add 1 is always greater than 0 for all x. Cool. Okay guys, paper done. Don't forget, this belongs to the playlist of every AQA higher GCSE 9 to 1 maths past paper, so they're all there in one place. Hope you found this useful. Take it easy, take care, good luck in your exams.